dunes form, and they form a habitat for the plants. But dunes have to be stabilized by plants or they won't persist. And so you have this kind of reciprocal interaction. The dunes provide a habitat for the plants, but the plants help stabilize the dunes. And so we started studying these about 15 years ago, kind of by accident, and started setting up some permanent plots on the tip of this island, St. George Island, and started following the vegetation every year and seeing how it changed. And we, again, kind of naively stumbled on the only real long-term data set for vegetation on barrier islands, almost in the world, but certainly in the northern Gulf of Mexico. And so when the oil spill occurred, this put us in kind of this interesting position. We were studying the dunes because we were just interested in basic ecological processes. When the oil spill occurred, however, we're one of the only people who had this sort of long-term data to be able to actually see whether or not the oil spill is having some sort of an effect. The long-term monitoring we're doing here, we have actually, sponsored by NGI and other places, we've now set up the same types of monitoring around the Gulf of Mexico. So we have plots on Trinity Island, Louisiana, plots on Horn Island, Mississippi, Fort Pickens, Mexico Beach here, Antelope Key, and down at Cayo Costa in southern Florida. So we're actually doing the same sort of sampling now at all these sites, though this was the original site where we really have the long-term data. You have to realize that barrier islands aren't only important because for their own inherent value, but they also protect inshore areas. And so they're protecting oyster beds, they're protecting salt marsh areas. They're also very important for recreation. They're protecting nursery areas for fisheries. And so we really do need to understand barrier island dynamics, and to do that we need to understand the plants on the barrier islands.